Okay, yay. So welcome to the Indy.net Consortium. My name's Ari Rahimzadeh. I'm one of the organizers. Tim is going to join in a bit. We're brought to you by Theoris, 1150 Academy, Ozcode, and Launch Fishers. We meet once a month on the first Wednesday of every month, generally every month, not usually around the holidays just because. And we hope that you continue to come to our presentations. Tonight, we've got a great presentation from Kevin Griffin on Signalr, the real-time revolution, Signalr in action. I'm super excited about this topic, just having used Signalr in the past, so very excited. Thank you, Kevin, for being here. We are also part of the .NET Foundation. So if you haven't checked out the .NET Foundation, definitely check it out. And we're part of the .NET Foundation virtual user group. So if you haven't seen the virtual user group, it's pretty cool. They take a whole bunch of the .NET meetups around the globe and put them in one meetup. So they don't take them over, they just link to them. But it's a great way to find good topics. And there's everything. It covers a whole bunch of wonderful stuff, including Signalr, like we're going to talk about tonight. This is my template slides. So for those of you that are new to us, just a few notes. One, I'll be monitoring the chat, so you don't have to you don't have to unmute. Put your question in the chat, and I'll find an opportune time to ask Kevin. Number one. Number two, don't worry if you have to leave tonight. It's okay. We're going to record it, and you'll be able to watch it. Just come back to the Indy.net Consortium meetup page, and the link will be part of the event. So just go to the event, and you'll be all set. And then, Kevin, I imagine, would you have time for questions after the presentation?
Absolutely.
Okay, great. So after the presentation, go ahead. I'll unmute all mics, and you'll be able to just start, asking away. We can just have a conversation. And without any further ado, I'm going to stop sharing my screen. And you're already a presenter, Kevin. I'm going to turn my video off because I'm sure everyone wants to see my face the whole time. And thank you very much, and looking forward to this. Take it away, Kevin.
All right, everyone. So you should be able to see my screen. All right. So cool. Hi, everyone. Make sure you're in the right place. Real-time revolution. We're going to talk about one of my favorite subjects, Signalr. I'm very glad that you're here with us. And let's start this conversation with a story. I've been working with Signalr professionally for almost 10 years because Signalr has been around for almost 10 years. And I go into a lot of different clients and help them with different real-time problems. And I actually had one not too long ago, probably about a year ago now. You know how COVID time is slower than most. But they have an app, and it doesn't look exactly like the one on the screen. This is the visualization of what their app would kind of look like. And it's probably nothing different than what you're working on or what you might use on a regular basis. There's some interesting icons up in the top right-hand corner of this client's app. And in particular, there's the alerts icon, and then there's the mail icon. So these serve two different purposes. One is the alerts, which is shared by multiple members of a team. So if something happens in the system that multiple people need to know about, it alerts, and whoever is paying attention to the screen can go look at the alert and go acknowledge it in some way, shape, or form. The second is an inbox for that particular user, and it's also inbox that could be potentially for members of different teams. And I do think there's an open mic. So what would need to happen in like any application, so if you use Facebook, you know that it does kind of the same thing up in the top right hand corner. When something happens, the number increments, it might flash, it might do something fancy. So not this is not like a groundbreaking feature by any means. The way that they achieved this was that they would have their app connect back to the server every couple seconds and would say, hey, I would like the number of unread messages. It would figure out which user was making the request and would send back the appropriate response. Do the same thing for notifications. All right, how many notifications do I have? Figure out who's asking and give it back the answer. But for both these requests, it had to go do the calculation because it would have to figure out who they are, what team they're part of, go to the database, run one, maybe two different complicated queries to figure out the answer. And then it just comes back to a number and sends that number back to the client. Well, it would do this each call every 5 seconds. And then I saw the intervals. All right, every 5 seconds, go make this call. And that's not a bad solution to the problem. All right, so if you're sitting out there thinking, well, that's probably what I would have done. And I want to tell you, that's probably what I would have done too 10 years ago. Let's talk about this process just a little bit more, and let's see where a disconnect might occur. You have your central server, and you have your one client that's talking to the server every 5 seconds. It's making 2 calls to get that update. And those updates aren't necessarily always productive. They might be the same data over and over and over and over and over again for periods of time. But it might not just be you connected to that site. It might be someone in another state, another county, another city, another department. They're all connecting to the same site, and they're all making the same request every 5 seconds for every browser tab that they have opened. This is just a compounding API call. And what they were noticing, looking through their different metrics, was that these 2 particular calls were dominating 80% of the time that their server was spending performing requests. And it wasn't that they were slow requests, but just the act of making these requests over and over and over again, they were having to do work. It was causing a slowdown across the entire system. And most of it wasn't even fruitful. We were making requests to the server. It was going to a database to get an answer that hadn't changed. And it was doing that over and over and over again. So they come to me and most of these conversations start the same way. Kevin, can you help us? Is there a way that we can do this a little bit better? Is there a better way? Cool. So those of you who don't know me, my name is Kevin Griffin. I'm a Microsoft MVP, going on hopefully 13 years, knock on wood. But my focus as a developer has been in ASP.NET to ASP.NET Core, building solutions on Microsoft Azure, and I love everything web development. It fascinates me. And I help businesses of all sizes come in and build robust systems with that stack. If you'd like to talk to me anytime after this session, you can always find my information at consultwithgriff.com. I'm very active on Twitter at @1KevGriff, and I'm trying to get back into streaming on Twitch. I used to do that fairly regular, but I fell off the wagon because of COVID stuff. So there's that. I also am the author of Signalr Mastery, which is a course on Udemy. We're about to hit 2,000 students. So maybe if everyone in this talk went and bought the course right now, like I will, you don't need to pay attention to me, because just go buy the course. All the information's in there plus more. Go buy the course. I'll get to that 2,000 student mark today. That would be amazing. But Signalr Mastery is the course that teaches you everything you might ever want to know about Signalr and building real-time web apps. But I'm not going to talk about that anymore. Let's go back to our problem project. So we have this app that's talking to a server, and ideally, we would want to open a WebSocket. If we were having this conversation 10 years ago, I would have to slowly introduce you to the concept of a WebSocket. But I think you all are hip enough to know that WebSockets exist, that they are a thing. So a WebSocket's kind of the ideal way for us to go. We have one connection between our client and our server, and the client can obviously use the WebSocket to send messages up to the server. But more importantly, the server can use the WebSocket to send messages down to the client when stuff occurs. Because we don't want the server to go, we don't want the client to go every 5 seconds and say, hey, do you have something new for me? Do you have something new for me? It's like your kids in the car saying, are we there yet? Are we there yet? Are we there yet? No, we're not. Stop asking me. I'll let you know when we're there. So something happens. Let's say a new email comes in. One of the services needs to issue an alert. The server knows that these events are occurring. So why not just use the existing WebSocket that we already have to notify one or multiple clients that something has occurred? And it's just simple state changes. The server is aware of a change in state to the infrastructure. Let's notify anyone, everyone that needs to know about that state change. That is the basis of every Signalr project I've worked on, is just that simple fact that the server knows something that the clients need to be aware of. If we blew this out a little bit more to all of our connected clients, instead of all these clients making multiple API requests every 5-10 seconds, they just open one request, keep that WebSocket open, and the server, when it's ready to send information down, can selectively send messages to whomever it wants. Awesome. Now, I've already kind of introduced the fact that we're going to talk about this in Signalr, but if we were having this conversation 10 years ago, we would have had to have a philosophical discussion of, well, WebSockets wasn't fully supported across every browser, every server configuration. How do you do this in other ways? How do you program against all these different ways? And we're going to cover some of the details in a moment, but the real answer was, you and I probably didn't do that. We would not have cared about the lowest common denominators. We would program against the higher, most common denominators. So most common being long polling, what this customer was doing. So it's easy, and it's easy to do, and it works across most configurations. You just open that API request every 5 seconds and get the data back. But it's not really the most efficient 10 years ago. With Signalr, the team, the ASP.NET team at the time, David Fowler, Damien Edwards, had this idea of, what if you as a developer could develop against a single contract, and the server, the service, could figure out the most appropriate means for a client and the server to talk to each other. That might be WebSockets, that might be other transports. What if they could just handle that part for you, and you just wrote code pretending like none of that exists? And that's what Signalr became. Eventually, you got an upgrade to .NET Core, and that's where we are today. But I want to jump out of slides for a bit. I want to jump into some code and show you probably the most basic example of Signalr that you will ever see. It is not a chat app, because chat apps are evil. It's just designed to show you some of the basics of Signalr, and we're going to talk about some of the more in-depth concepts. So let's jump into some code. All right. I have a project. This is available up on GitHub. I'll make sure I share the links with everyone so you can go look at it afterwards. It's labeled as Signalr Mastery, and it is the Signalr Mastery repo. You do not need to be in the course to get all the source code for it. That's all just available to you. I would prefer if you were in the course, signalrmastery.com, but you don't have to be. All right, I'm pretty sure I've cleaned this up enough. This is a really simple application. Let me load it in the browser. So say .NET Run. Let's see. Oh, yeah, I didn't clean it up well enough, did I? All right, sorry. was so close, so close. Still so close. There we go. All right, this one's the winner. Okay, so let's load this up in the browser, and it doesn't do anything. It just loads this page. And I know what you're thinking, Kevin. This is the ugliest thing I've ever seen. Yes, me too. But here is what our intention is, to teach you just some of the basics of Signalr and real-time web development. I'm going to have a page, and I'm going to duplicate this tab. So I will have two pages. They have a text box on it. They have a checkbox on it. There's buttons, but we're going to come back to that in a moment. And what I want to have happen is when I type into the box, whatever I type in the box, is going to seamlessly update the text box of any other instance of this website. That's it. We want to communicate state changes from one client to the server, from the server down to other clients. Let's start in the beginning. And the beginning for .NET is the startup CS file. I am still using startup CS. I'm not doing the minimal APIs crud that they're trying to pawn on all y'all. You could do that, and I have examples of that, but I'm still using startup CS for this example. And what we want to do is we want to set up Signalr. Most talks like this go, all right, go to NuGet, go search for Signalr. You don't have to do that if you're building an ASP.NET Core app. It's already in the bundle. It's just part of ASP.NET Core. But what you do need to do is you do need to go add your injections. So we'll say services.add Signalr. I do have GitHub Copilot turned on, so we're going to test GitHub Copilot to see how well it can figure out what code it is I actually want to write. It's not always correct. So we've added our injections. Yay. Now we need to set up something on the server to accept all these awesome incoming connections that we're going to have. And that starts with a concept called a hub. So I'm going to create a new folder. You can call it whatever you want to. I'm going to call it hubs. It does not need to be in your web project. It can be in any other assembly as long as it can reference the appropriate assemblies. You're good to go. I'm going to add a file called sync hub. You can call it anything you want to. This is not convention based. And a sync hub is just a class called sync hub. And we're going to implement the GitHub Copilot's a step ahead of me. It's going to implement an object or abstraction called hub. Done. There, you have a hub. We don't have to actually put anything into the class to make it hub. There's nothing you have to override. It can be empty, and this hub can accept incoming connections. Think of a hub kind of in the same way you would an MVC controller with the big old asterisks on it. It is a central connection place for incoming connections. It's like an airport hub where multiple flights are all coming to the same place, or a train station hub. It's one place for everything to go. Think of a hub that way. Also think of a hub as you're going to have one WebSocket. This is the one place that WebSocket is going to go to. You could technically have multiple hubs, multiple WebSockets. We're not going to go that deep, but you could technically do that. All right, I have my sync hub. Yay, that's all great. I need to tell ASP.NET how to direct people to this hub when they attempt to connect. And we go back to the startup CS file to do that. And theoretically, this is an endpoint. So if I'm using endpoints, I can say configure map hub, and I can pass in the generic sync hub telling ASP.NET Core, when you see a request come in for, technically I want this to be hub/sync. When it sees a request come in for hub/sync, redirect all those requests into the sync hub context. All right, that part's done. Let's move over into JavaScript land. I've already added some code here. Essentially, all this is doing is getting references to that text box, the checkbox, and the buttons. And I've wired up some basic event handlers that we'll use a little bit later. But other than that, I haven't added any other code here. I have also taken the opportunity to do an npm install for the Signalr package, which is at Microsoft/Signalr. The best way to use Signalr in a JavaScript application is the npm install that package. If you're working with TypeScript, awesome. That is the best way to use Signalr. It's just fully supported, written that way out of the gate. If you're using JavaScript, that works as well. If you're working with a build system like Webpack or Angular or React CLI or Vue CLI is what I use a lot, those all just work flawlessly, no problems. If you're writing vanilla JavaScript and you're not using any of those fancy build systems, you just need distributable JavaScript files. Those are in the package as well. And it's actually what I use. So you can see I'm referencing my node modules. There's a distribution folder, and I'm getting Signalr kind of added to the page for me. This is what I call the old jQuery demo. This is how we used to build JavaScript applications back in the day, and it worked really well.
Hey, Kevin.
Yes.
We have a question.
Okay.
And, Alex is asking if that's what about with Blazor?
We don't talk about Blazor.
We're going to talk about Blazor. Okay.
Now, so I don't.
Question, Alex?
We don't talk about Blazor. Blazor doesn't when you use this process directly. Blazor, depending on how you're using Blazor, that's a discussion for later, because I have not done enough Blazor to give good feedback on that. A lot of Blazor apps, if you're taking full advantage of Blazor as the Blazor platform, you're actually using the .NET client for Signalr, which is really good. You're not worrying about all this fancy JavaScript stuff. So that's kind of the answer. That's like half the answer. But if you are using Blazor and still writing JavaScript and all that good stuff, you're probably more likely using like the TypeScript clients. You're going through some sort of build system. I don't know anyone who writes JavaScript like this anymore. It's usually always through some sort of build system. So you're not doing this per se, but it would take me 20 minutes to explain how my build system was set up for Signalr development. So we're just going to skip over all that stuff. But good question. And I was kind of joking about the Blazor stuff. We can talk about Blazor if you want to. I just won't be able to answer much. All right. So we have Signalr on our page. I've toastified because we're going to have some fancy post pop-ups a little bit later. And then I have my JavaScript file. And so first thing we want to do is we need to get this page connected to that hub. And that's done with what's called a hub connection builder. So we'll say, all right, connection is equal to new, and it's figuring this part out for me already. Hub connection builder. And this is set up very much like building things in C#. So it has a fluent interface with it. We can tell it to use a URL. And I'll say, all right, hubs/sync. All that needs to match is this needs to match what I'm expecting in my startup CS. Signalr will take care of making that a fully qualified URL. And then I'll say build. Now, between the hub connection builder and build, I can add a variety of different options. I can turn on logging. I can set up access tokens. So if I'm working with an API that I want to authenticate against, we can do all that. If I want to change how messages are sent across WebSockets, I can change all that good stuff. We're not going to go that deep. All I really want in this case is I want a connection. Now, this connection is kind of useless because I haven't told it to connect yet. down here at the bottom, we'll say connection.start. This tells Signalr, go to the server, hub/sync, figure out how to do the connection, and let me know when you're ready. We come back out to our command line. Let's see. I should run .NET Watch, but I've had some issues with it lately, so I'm not going to do that. New space hub. Using Microsoft. There we go. It's always the little things that mess you up, right? All right. So let's go back into our page. I'm going to bring up the dev tools. I don't think enough people go into dev tools to show off things like this. Let's hit refresh. And you'll notice, where's my, go away. I have some logging in here. First, I have a message that says normalizing hubs/sync into a fully qualified URL, which so it's not just hub/sync, it's localhost port 5001 hub/sync. Signalr then makes a call to that endpoint and it does some negotiation. And it doesn't have all the fancy logging in there for that because we don't have it turned on. But they figure out, the client and the server, that the best way for them to talk is through a WebSocket. So we make a WebSocket connection. WebSocket connected. We can go to our network tab, and I have everything zoomed in a lot, but we can see right here, there's my sync hub. It has an ID. Every connection has a connection ID that's unique. So every tab would have a different connection ID. It's always guaranteed to be unique. And we can see it's pending because this is an open connection. You can go to the messages, and let's see if I bring this up. I'm going to zoom out just a little. This is every message being sent over that WebSocket. All Signalr is doing at the moment is sending heartbeats. Are you still alive? I'm still alive. Are you still alive? And then it goes back and forth. It uses this to detect when connections are possibly disconnected, but not fully disconnected. I call it the hotel Wi-Fi condition or a conference Wi-Fi condition. It's gone, but not completely dead yet. It will figure that out. So nothing's happening here. But there we go. We have a connected Signalr application. Yay! We should give ourselves a pat in the back. Let's take a moment and talk a little bit about protocols, because this is a fun discussion all on its own. Now we know that WebSockets is the holy grail solution for everything. If I have multiple clients out there and I have a server, they can connect to each other one-to-one. The clients talking to the server. If the server needs to send anything down to these clients, it just uses the existing WebSocket. And likewise, the clients can use the WebSocket to send messages back up to the server. Nothing too special there. But what if WebSockets aren't available? And you might be thinking, well, Kevin, why would there be a case that WebSockets aren't available? Well, sometimes this happens. We've seen it before on certain servers where if you're self-hosting this stuff on your own boxes, why are you doing that? But if you are, you might have it configured to not accept WebSocket connections. That's happened numerous times. If you're running behind a proxy or a VPN, some of those services are set up to not allow WebSocket connections, so you might get limited there. What do you do if your clients and your server can't talk via WebSockets? Naturally, you want to fall down to another protocol that's still widely supported. In this case, we have one called server send events, which cookie to anyone out there that knows the browser that introduced server send events. Because we're not in person, I'm not going to ask, but it was Netscape. This is actually an old Netscape protocol. And it works kind of like this. You have your clients and you have your server. And the client makes an initial request to the server to ask it to create what is called an event source. So an event source is just a connection from the server back down to the client. And when the request gets cleaned up, the server can use that event source pipe basically to send any messages it needs to down to the clients. This is one way though. That server can use this event source as much as it wants to. But if the client wants to send any messages back to the server, it has to open a new HTTP client request. So you're effectively falling back to just good old AJAX to send messages up to the server. But this is slightly better than the worst case scenario, which is long polling. The long polling you probably have heard of. There's another version of this called interval polling that Signalr doesn't support, thankfully. But the idea is that the client opens a request to the server and it just leaves the request open. When the server has something that it's ready to send back, it will look for that open, basically that open socket, that open request, and it will use it to send the response back down to the client. And then the client just rinses and repeats. All right, let's open the new request and let's wait for the server to have something to send back down. The server's going to do a little bit of work here to batch messages up. So if it's a particularly chatty line, it's not requiring a new request for every message that needs to come down. It'll batch a lot of that stuff together. But effectively, your server is going to stay here with an open connection, and it's going to wait either for something to be ready to be sent back down, or it's going to wait for the connection to time out, which, depending on the browser, might be 2 to 5 minutes. It really depends. You can override that in a lot of cases, but let's just assume 2 minutes. The browser is going to close the connection because it's going to assume nothing happened. Signalr will establish a new connection, and everything just keeps on moving. So these are the 3 protocols that Signalr uses to communicate between a client and a server. We have WebSockets. The big pro there is it's an always available connection. The big con is you could technically exhaust your socket pools on your server, because if everything's open via a WebSocket, those are socket connections not available for other things to be done, like serving up HTML or JavaScript or API requests. If we have time towards the end, I can tell you the story of how I DDoSed myself, and I learned this the hard way. It was a mistake, but just something to keep in mind. Server-side events, if you have to fall down to that, it's a really good fallback. The biggest issue is that the clients can't use the existing event source to send messages up. It has to go through other AJAX requests. And then finally, long polling. This just works really well on all browsers. We could go back to IE6, IE 5.5, and this would work. No problem. Hopefully you don't have to do that, and that's not a worry. But if you have to, this is a good fallback. The biggest con is you're constantly reconnecting to the server over and over again. And if someone were to become permanently disconnected, you don't know about that for a period of time. There are mechanisms in Signalr to detect when people connect and disconnect. And with WebSockets, it's immediate. Oh, new connection. Oh, they've disconnected. And long polling, you just don't know until a period of time has lapsed. So there you go.
Kevin,
yes.
We have a question.
Okay.
How easy is it to establish? How easy to establish it with an authentication layer? They use Identity Server and are looking to implement Signalr soon. Sure.
If you are using anything that implements iPrinciple, so ASP.NET Core Identity Server, in a lot of cases, it is seamless. Signalr will obey all the ASP.NET Identity attributes. So if you decorate a hub or a hub method as authorized or authorized for a particular role or a particular set of roles, it will enforce all those, no problem. If you are connecting via, say, bearer tokens, you can do that too. I have a video on that in the course where we talk about that. It's a slightly different process. Just because ASP.NET Core in particular does not, they support bearer tokens, but they don't make it easy on you to support bearer tokens. There's still a little bit of heavy lifting. So there's not been an authentication process that I haven't seen work. The other nice thing is you can authenticate not just at the hub. So actually, we're getting ready to jump back in the code demos anyway. So I'll continue answering this. You can authenticate at the hub level, or you can authenticate at the individual method level inside of the hub. So if you have a case where, all right, so this one's a create send message. If I want to restrict send message to only administrators, I could do that. So in the same way as an ASP.NET controller, you can protect the entire controller or individual actions on the controller. Signalr works the exact same way.
Okay. Thanks. We have another question.
Sure.
What alternatives are there to using JavaScript with Signalr? So JavaScript Edge or Chrome with Signalr?
Yep.
Like desktop, WPF, WinForms apps, Xamarin mobile apps, and so forth.
Yep. So that was more a discussion for the end, but we can talk about it now. The benefit is that there are a variety of Signalr clients for different platforms. I'm talking solely about JavaScript here. I talk mostly about JavaScript in the course, but there's a full .NET client as well. So let's say you're building a console app or a WPF app or a Xamarin app or a Windows service, and you wanted these individual services to connect to your server in the same way your web app might. Well, there's no changes to be made on the server. The server is just the way it's going to be. But the individual clients can connect to the server in the same way as I showed right here. You create the connection on whatever platform, right. Tell it where to connect, and it will establish the connection. It's the syntax might be a little bit different, slightly, but the concepts are all exactly the same. You're setting up event handlers on your client to listen for messages coming down the pipe, and then you're emitting new messages whenever you want to send stuff up to the server. So there's a really good list of variety of clients up on the Microsoft Docs, and there's also in GitHub. There's not in the documentation, but it's on GitHub. There's the specification for a Signalr client. You could theoretically go write your own client in any language you wanted to. David Fowler is famous for doing talks to like Indy and such, where he'll just sit down and go, let's write a Go client for Signalr. And he writes one based off the specification, connects it to an existing service, and it just works flawlessly because the specification is there and it's open source. So everything that you listed, desktop apps, Xamarin mobile apps, those are all already covered. There's already a Java client. There's a C++ client, but they're reworking it right now. It's not as efficient as they want it to be. But you should be 100% supported.
I did have a follow-up to that. Is that where Blazor would come into play, that you could use, the .NET library, since it's just going to go send that over? What is it?
Yeah.
WASM, when you do the server-based stuff? Yeah.
Yep. Pretty much.
Or the non-server-based stuff. It sends it all over. Yeah.
So yeah, it depends on how you're using Blazor. But you can use either clients. I've seen plenty of examples using all the Blazor server-side stuff, and it's using the .NET client underneath the scenes.
Right.
And still using WebSockets, server-side events, or long polling, depending on how it wants to make that connection.
Great. I had one last question. That was my own, which is when you said authorization would work. I've been playing around with Auth0.
Yes.
And does it work with Auth0?
You're probably falling into the access token bearer token scenario. Yep. So the answer is yes. The short answer is yes. The long answer is yes. You have to write some additional code that's not documented very well. That's why it's in the course.
Got it.
So
Okay.
not trying to plug my course, but I totally talk about that in the course because I had one of the examples I'm going to show at the end of this talk is using bearer tokens. And so I had to figure all that stuff out a couple of years ago. It was not.
Got it.
It wasn't super intuitive, but once you get it working, it works great.
Awesome. Thank you.
Yeah. All right. Let's jump into sending some messages. And we're going to talk about this text box first. And all I want to have happen is when you type into the text box, it's going to send that content up to the server. The server is going to turn around and send it back out to anyone else who's looking at that web page. That's all it's going to do. Let's just add some code here. So I already have my connection. I already have a reference to my text box. Let's go over to the server first, and let's create a place for Signalr to send that message. Yeah, you know what? No, I don't want to call this. So we're going to say async task sync text box. That's a better name for it. We're going to pass a string text, and it's jumping the gun here a little. I'm going to then turn around and ask Signalr to go to all my connected clients. And so this client's object we get because we're implementing Hub. So all my connected clients, I want to filter this down to say, all right, everyone, which that's not exactly what I want, because if I'm sending the message in from my tab, I don't want to send it to myself. Let's send it to everyone other than me. All right. So all the clients, let's filter that down to just the clients that aren't me. And I want to send a message to them called sync text box, passing in that original value. Now you're going to see here, this is a magic string, and magic strings are, no one likes magic strings because it is easy to screw up a magic string. There are other ways to strongly type all these calls, so you don't ever have to worry about a magic string on the server. It's in the course. So we're going to send a message to all the other clients, telling them that they should execute a local method called sync text box, or they're going to receive an event called sync text box. I'm awaiting this. Here's pro tip. You get this one for free. Everything in Signalr is asynchronous. You should await everything. I have made a lot of money off people forgetting to await these calls. So don't be that person. Await all these calls. All right, so we're going to say sync text box. We're going to get some text in. To recap, we'll go to all the other clients who are not me. We're going to tell them to call their we're going to pass an event, sync text box, and we're just going to pass that value down. So then over on the client, back in JavaScript land, we're going to go and create a text box or add an event listener. And we'll just say change. And when that happens, yeah, I got some sample code here. Go get the target. What's the text box? And we're going to tell Signalr, right, take our existing connection. We want to invoke an event on the server called sync text box. We're going to pass in the value of that text box. And notice that matches that. Casing doesn't matter in this case. All right. Now, type in the text box. That chain or hit enter, do something. That issues the event handler. We get the text box in memory, take its value, send it to the server, telling the server to invoke the event or the method sync text box. Comes back here, passes in that value from the text box. We go to every other connected client, telling them to call their local events sync text box. I'm keeping the names all the same here just to show the flow. If I'm on another tab, how do I catch this event? Well, everything is just pub sub. So on my connection, I'm going to listen for an event, say on sync text box. And when this occurs, I'm going to get whatever that text it's setting down is. And we'll set the text box value to text. Okay. Let's assume I did everything correctly. That's most of my day, is just assuming I did something correct. All right, let's restart the application. What did I screw up? Task cannot be found. Oh, because all my usings are gone. Hey, fun. All right, someone out there, tell me where, what's task in? Microsoft, was it system?
Threading. System
threading. All right. Sure. Are you sure? You sure? Dot tasks.
Yeah. Dot tasks.
Yeah, I mean,
system.threading dot tasks. I know it's in system.threading.
All right. Legitimately, the last 2 or 3 times I've been in this talk, I've had to ask that same question. I get to that point, I'm like, oh crap, I forgot where this using statement is, and I'm in VS Code, not getting any help. All right.
It should be task should be in system.threading because tasks use task, which should be above it. But whatever, I digress.
I don't know. All right, let's set up an example here. So I'm going to go ahead and we're going to ask Windows 11 to put everything in the corner. There we go. All right, so I'm going to refresh both these pages. I'm going to type into this one and hit enter. Notice over on the other side, it gets Kevin. Boom. To show you it's not Fluke, I'll go to the other side, type my other name. He goes to the other side. And it's not just these 2 browsers. I can open as many of these browsers as I want. And they all sync the value. So cool. We basically have done what I charge a whole lot of money for. Not really. But we are solving the fundamental problem that I see 95% of people that use Signalr for. We do stuff on our site or in our apps or in our services, and the server detects these changes and sends state changes down to individual clients. So yay. Let's talk real fast about this checkbox. And I have the checkbox on here to show you that even though I'm passing strings into my hub methods, you don't have to work strictly with strings. You could also set up, oops, I'm going to copy and paste some code just because that's a little bit easier. You can sync Booleans. You can sync complex objects if you wanted to. So if you have a class and you want to send a full object down to a client, or send an object from a client up to the server and have it bound, Signalr will do that. It's going to communicate all over JSON, and it will take care of the serialization and deserialization for you. So let's just talk sync checkbox for a second. It's the same process as before. Everything's synced. I'm going to go over to my index.js. We'll set up the connection handler for when checks come in, and we'll set up the event listener for when the checkbox changes, and I want to send that message to everyone else. Yeah, assumed I did all that right. Let's go ahead and shut down the app and restart it. Go ahead and bring up 2 browsers, refresh. I'm refreshing just to make sure I get the latest code and reestablish a connection. But all right, so Kevin, that sync works fine. And then if I hit the checkbox, you can see the checkbox is updating in both pages. Yay. So we're getting that real-time state sync down to anyone that's listening. I really should do an example with a console app that's listening for the same messages. That's pretty straightforward to set up. But cool, we are doing basic basic communication to our clients. Well, speaking of clients, let's talk more about clients, because this is another place where we can really get down in the weeds.
Hey, Kevin,
Yes.
I had one quick question about that. When you said you could send complex objects and it works similar to the serialization and deserialization that happens in like ASP.NET Core.
Yep.
Is it like duck typing where it'll like .NET ASP.NET Core, if there's a close enough match, it'll map it?
Yes.
Okay.
So basically, underneath the scenes, it's running the system.text.json serializer.
Okay, got it. Thanks.
So if it can figure out how to serialize it to JSON and then deserialize it from JSON, it's going to work.
Okay.
Flawlessly.
Thanks.
So basically, what I say is, as long as you have types that are serializable, you're good to go.
Cool. Thank you.
Yep. All right. So let's talk about clients for a moment, because this is actually a piece I have ripped out of the course, where we have our server and we have a variety of different clients that are connecting. And notice I have them labeled A, B, C, D, E, F, and so on. And that's to represent that they all have unique IDs. So the unique ID for A is A, for B, and so on. When I'm on the server and I want to send a message to my clients, I need to be specific about which clients I want to send messages to. And I can set this up in a couple different ways. Now, we had seen clients.others in the example, but let's start at the very beginning with one of the more common ones, clients.all. And that's straightforward. All connected clients will receive this event and be told to invoke a client method. So the server sends that message to everyone. Easy. There are some cases where, let's say I'm client A and I make a call to the server, and the server wants to send information back to just me because it's only something I'm going to care about. There's a couple different ways to actually solve that particular problem, but one of the more common processes is to use clients.caller as the method. So clients.caller means the server is going to send a message only back to my connection ID. Awesome. Clients.others, this is what we used in the demo, means if I send the request up, I'm client A, well, everyone else is going to get a message instead of me. Mostly because I already know what's going on. Why do I need to get that message in response? You can filter this a little bit more. Let's say you want to send a message to all clients except the clients C and E. We can filter those folks out. We can filter out those connection IDs. I have it here as a param list, but you could pass in an enumerable with a bunch of IDs in it, however you're storing them. So this ensures that only A, B, D, and F get the message, and C and D, or I'm sorry, C and E are completely left out. Now, because we're talking about connection IDs, we can send to particular connections if we need to, and that's called clients.client. And I can pass in a connection ID telling it, all right, this message should only go to Jim's tab in his third Chrome browser. That's exactly where that message is going to go. I'm showing this to you just to tell you that it's something that you can do. I don't advocate for using this process. And I've written 1 or 2 articles. I have videos on it in the course. I don't think you should do this. Mainly because I don't think connection IDs are super useful in load balanced scenarios where you have multiple servers. We can talk about that a little bit later if you want to, but I don't advocate for using connection IDs like this. But if you were, you could specify multiple connection IDs. So let's send this to clients D and F, and that works exactly the way you would expect it to. We talked about identity a little bit earlier and authorization. If you're using an identity principal, you can reference a user by their identity principal. So here we have A, B, C, D, E, F, and they're mapped to certain users, Sally, Kevin, Kelly, so on. If I want to send a message to only the tabs that Kevin has open, I could say client-side user Kevin or whatever my principal name is. And Signalr will figure out which of these connections are mapped to Kevin. I've had...
Hey, Kevin?
Yes.
I'm glad that you're talking about Kevin. All right. I thought it was funny for a moment. We have a question. Will
Sure.
you talk about connection mapping?
I could. Need to go a little bit deeper with that question, because
Okay.
it means that means different things depending on who's asking.
That might be a good question for after your presentation.
Sure. Yep.
Okay. Got it. Thanks.
Alrighty. All right. So we have client-side users. Kevin gets all of the messages. We can say multiple users. So Kevin and Sally. And again, this is the I principle. So it might not be Kevin. It might not be Sally. It might be Kevin at contoso.com and whatever. Signalr is going to look at the connections and it'll say, all right, well, I should send this to Kevin. I should also send it to Sally. And it's going to figure out all the stuff in between. Now, there's another method for setting up folks for sending messages, and it's the concept of groups. So I think I just want to jump in the code on this one, just because it's more entertaining this way. Let's go into our code for a moment. Let me shut all this stuff down. And what I didn't show you at the beginning was in my startup class, I have this hosted service that's just sitting out there running. It was doing work, and we didn't know anything about it. And the new user worker is just a background service that is generating new users on a regular basis. So every 10 seconds, it's generating a new user. You might have seen it in the logs here, generating new user, so on and so on. So this is emulating state occurring behind the scenes that we want to notify our clients about. So A, how do we notify clients that this work is being done? And B, this might not be something that everyone needs to know about. So how do we set this up to work only for people that want to know about these particular cases? Well, let's go to our sync hub, and I'm going to add two more methods on here. One's called start notify, and I'm going to set another one called stop notify or end notify. Might as well stay with my demo. The start notify is going to map to the button start notifications, and then end notify is going to map to end notifications. Well, when I start notifications, I want to add myself to a group that will later receive these notifications as they occur. We know clients exist because we're implementing the hub, but I also get another method called groups. I'm going to await groups.add to group async, because everything's async. I'm going to go into the context of my connection. So we think of it as my particular tab is talking to this method. There's a context for my connection, which has all kinds of useful stuff in it. And IntelliSense is going to fail me, but just trust me, one of the objects in here is called connection ID. There's also like the original HTTP request, if I want to go look at that. So if I want to pull headers, there's all kinds of useful information inside the context. What I want to do is I want to take my ID and I want to tell Signalr to map my ID into a group called, we'll call it notify me. I'm now in that group. When I want to no longer be in the group, I can tell Signalr to remove from group async. And the same thing, just grab my connection ID and remove me from the group, notify me. These are magic strings again, but these are good magic strings. And we'll talk a little bit in a couple minutes about just some group naming theory and how I use them in production apps. All right, so I've started notify, I've ended notify. Let's go into my new user worker, and notice I have this big old to-do here. And I need to tell Signalr that I want to send a message to the group, notify me. But I'm not in my hub. So how do I get access to those clients into that connection? And this is one of the more common questions I get from folks jumping into Signalr for the first time, is when you want to send messages, but you don't have access to this client's context. How do you get that information? Well, you're running ASP.NET Core. All this stuff is injectable. We're going to inject an iHub context of type sync hub. And what's great about this is Copilot sucks. All right, let's not just Copilot. There we go. So we're going to add a hub context, and we'll pass in hub context. We'll add our private variable. I'd let VS Code do it for me, but I don't trust it. All right, so I have my hub context that will get injected at the time this new user worker is instantiated. Fun fact, hub context is a singleton, so if you're worried about scopes and all that cool stuff, you don't need to worry about it here. Hub context is really fun because anywhere I need to access those clients, whenever I need to access those clients, I can just go to my hub context and ask it, all right, give me all the clients. Well, we don't want all the clients, do we? We want a group of clients. So go to the group, notify me. And from that group, I'm going to send async. We'll call them event new user. And I'm going to send a complex object. I have this R up here. I know it's R. It doesn't mean anything. Well, it's really R results.first. And we're going to send this very complex object down to the clients that are asking for it, and they'll know about the new users. Before I forget, let's make sure we await that call because we don't want to screw that up. Back to the server, I'm sorry, the client, and we're going to set up our event handlers for button start, button end, and these are pretty straightforward. I'm just going to copy and paste them in here, just to save you all from me typing furiously. So start notify and notify. And then I'm going to show some toast just to visually display that we are starting and stopping. All right, start notify and then notify map to the methods start notify and then notify. Now I also need to handle the case of when the new user worker calls the new user event. So let's go ahead and go up here to the top. I'm going to copy and paste this again because we don't have to show you how the connection handlers work anymore. You could probably have already gotten that. But for the connection on the new user event, I'm going to get a user object. So remember, fully, like a full object can come down. It doesn't have to just be native types. And I'm going to post a message, welcome name.first. And I'm also going to put a picture in the little toast so you can see what the folks look like. All right, let's assume I did all this correctly. Hit .NET run. Of course, group, what did I screw up? All right, so let's go to completing in here. Clients.group, that's correct. Group does not exist on the current sync hub. Oh, okay. It's groups. Yeah. All right. Sorry about that, folks. I'm going to clear the screen. Try that again. I'm going to save that for later. Let's refresh the screen. I'm going to start notifications. You can see my little pop-up there. And hey, welcome, Nadia. and there's their picture, and it's going to keep flooding in these requests as they come. I'm going to duplicate the tab, and we'll test, make sure everything else works. So Kevin, all right, so everything's syncing. I'm going to hit start notifications on the lower box, and they both get the message at the same time. Welcome, Jessica. And we'll wait one more. We'll actually wait two more. So welcome, Bertram. All right. I'm going to go back to the first box and stop the notifications. I haven't done anything on the server. The server's still doing what it's doing. Angela. It's probably Angela, right? It's still getting notifications because that tab is still in the correct group. Welcome, Ryder. It's still going to keep getting those messages. So I just showed you two very important concepts. How can we filter users into different buckets depending on what messages we want them to receive? And how can I send messages from outside of a hub, which is probably the more common things that you're going to do. Let's talk about how I use groups kind of in my apps. I'm going to gloss over some of this stuff just because I don't think it's useful. The basic concept that I just showed you was you could have multiple connections in one or more groups. So A, B, and C are in the yellow group, D, E, and F are in the orange group. If I say clients.group and want to send a message to that group, it will automatically find all the folks in that group and give them and send them the message or invoke the event. I can do exceptions. So if I'm going back to group IDs or connection IDs and I don't like them, but you could say, all right, everyone in orange except E should get this message. We can do that. I can send the multiple groups if I have multiple names that I care about. So groups yellow and orange, they can all get the message. Likewise, I can do others in group. If I'm in the group yellow and I send a message to the server can respond to everyone else in that group other than me. That all works really well. So where do I use groups in my project? And this probably will lead into the discussion if someone wants to talk about connection mapping. I use groups a couple different ways. One of the things I will do by default is anytime a connection is created on the hub, I will map that user to their own personal group. So Kevin, I connect. I know that I'm connected. I will add that connection to a group called Kevin, or it's usually a little bit more complicated than that. It's like the username, ID, whatever uniquely identifies me as a user. And it's set up in a way where if I ever need to send a message to all Kevin's tabs or Kevin's connections, I can recreate that magic string on the fly. I will do that. I will add users to particular groups if they're in certain cases. So if there's an administrator group, I will have an administrator group with all the connections for administrators based off roles. I've seen it done with different departments. So if you have a sales department, marketing, so on, you put people into those groups. We use groups depending on what view you're looking at on the server. So actually, I'll show off one of my favorite client examples, and that's Livecat. So Livecat is, I'm going to full screen this for a moment. Livecat is an app I built many years ago. And what it does is it does 911 aggregation for Southern Ohio, and you're all in Indianapolis, so you kind of understand this concept of there's a lot of podunk towns in the United States, and we still need to provide emergency services to these different towns, even though the closest emergency services from you might not be in your town or county or township or whatever you call it. It might be in the county next door. So what they've done in Southern Ohio is they report the 911 information for all these different towns and counties and townships, and they aggregate them into these collections we call them configurations, but they're basically big groups. So when I go to view this configuration, this is the combination of data from multiple counties, all on one dashboard. And I should probably start this conversation by talking about how I even got on this project. It was very many years ago. I was brought in, and the request was, Kevin, we have this app, and it was an ASP.NET Web Forms app where the entire screen was a big update panel. And the way update panels worked is they would re-render the entire page. It would send the response down to the client, and the client would only update what should be inside the update panel. Super cool back in like 2007. Today, it was just over-engineered and not useful at all. But the way the screen updated was it would go to the database, run this very complicated store procedure, and it would figure out all the colors and where things should be positioned. It did more than a SQL stored procedure should probably do, bar none. But then it would come and update the page. And it would do that for everyone that was connected to the site every second. Every 1 second, this update panel would go execute this sort of procedure and update the state, even though obviously nothing was updating. So kind of goes back to that original scenario I was talking about. We're doing work without necessarily getting anything from it. So it would sit there and just do this over and over and over again. They were adding users, and this is the digital equivalent of radio scanners. So when I was a kid, my dad would always have the police scanner on, listening to things happening around town. There's an entire group of folks that do that online now. They just watch these different dashboards and figure out, oh, something's happening in Pinkerton. Oh, hope it's not old man, whoever. Oh, something bad happened. Sick person. So you can see this information is coming in real time. So we went through and we rewrote the entire application, the entire structure of the application to use basically events. We are still collecting the information in real time, usually anywhere between 1 to 10 seconds. We'll get information from a 911 dispatcher, and we process it and run through a whole bunch of rules. And from those rules, we figure out which of these configurations we should send notifications to. It might be one configuration. It could be like 15, 20 different configurations all get the message that there's an event, there's a sick person, Hebron, or Newark, or whatever. So we go notify just the people that need to know about these state changes. When we pushed it into production, the original app that was running the update panel was 100% CPU all the time. The web server is running on the same machine as this SQL database. Like, it was not a good combination at all. But you live, you will learn. You tweak and you move on. We pushed this into production, and we were watching things, and CPU just sat at 0%. It wasn't doing anything. And as a developer, I just started freaking out. I'm like, oh no, I broke production. This is not working at all. But it was working fine. It just wasn't doing any work because there was nothing to do. We got the initial data set from the 911 operators, and it sent out the information, but then it was just in there waiting for something to happen. And we eventually started seeing, as new events were coming in from 911, we were seeing the updates up on our screen. And the server wasn't breaking a sweat at all. It was just sitting there waiting very patiently for data to come in. But fast forward a couple months, we've had this in production, and we find out that there was a call. It was a firehouse in somewhere Ohio, and the way they use Livecat is the firehouses and emergency services keep these up on big screens. And thankfully, we have not seen an alert come in. That's important, because what happens is the screen flashes bright red for a couple seconds, and that tells you that there's something important that you need to be aware of. And if you're on Firehouse, it's usually saying, here's a call you're going to have to respond to. That's why we're flashing. So Livecat was up on the screen. The screen started flashing. All right, bright red. They looked at it and went, yep, that's the call we'll respond to. They get their suits on. They get in the truck. Doors opening. They're heading out the door. And as they're heading out the door, dispatcher comes over the loudspeaker saying, hey, we need you to respond to a call at so-and-so. There's a person having a stroke. And they were already out of the door by the time this dispatcher had come on. So we're talking the matter of seconds, minutes of time saved by the app showing the run before the dispatcher was able to get on the loudspeaker. And anyone who's either gone through a medical emergency themselves or has had a loved one have a medical emergency, there are cases like heart attacks and strokes and whatnot where every second counts. And here we have taken a very basic web technology and we've implemented it in a way that has shaved off a ton of time in the response from emergency services for folks who are not necessarily close to emergency services. So that person, whoever had the heart attack, had the stroke, they got help sooner because we were able to just send that message down to the particular television that someone was looking at in a firehouse. So that's why I now say I save lives with Signalr. And if you ever hear me say that in the future, that's the story I'm going to tell. But underneath the scenes, all we're doing is we're putting people into groups and we're sending messages to the particular groups that need to know about it. Everything I have shown you in this talk is what I use in this project and in other projects. So it gets more complicated like anything, and that's what the course is for. But this is basically the culmination of there are state changes that the server is aware of that it can just send down to all these individual clients when they need to know about it. And yeah, this has been working flawlessly in production for a lot of years. We started as it was a rewrite in .NET Framework 4.6, 4.7. We did a transition to .NET Core a little bit later on, and it's been running nonstop. And it's been working great. And we've added users to it, but haven't necessarily had to scale the system just because this is working so flawlessly. So that's why I love talking about it. I love talking about Livecat. And there's a whole section on that in the course. But that's probably a good place to wrap it up and answer any questions that y'all have. Again, thank you all so much for hanging out with me today. Reach me here if you want to chat more. If you're interested in Signalr Mastery and you want to learn more about Signalr and all the different facets that I couldn't talk about in this session, go to signalrmastery.com and help me hit 2,000 students by the end of the week. You can do it. Thank you so much. All right, what do we got for questions?
Hey, thank you very much, Kevin. That was fantastic. So we have a question from Jeremy Worcesterfield or
Yep.
Worcesterfield, pardon me, Worcesterfeld. I'm gonna get it right. It's from Jeremy. What kind of exception handling and retry capabilities are there, such as if a message is being sent to a client and it gets dropped or missed because of network trouble?
Yep.
Yeah.
So none. You have the connection between the client and the server. There is no guarantee that a message from the server is going to make it to a client. Let's go a little deeper into that.
Yeah.
Likewise, depending on how you make the call from the client to the server, you can know whether or not the server received the message. There is no acknowledgement model built into Signalr because it's impossible. Because let's talk about this. The server sends a message down to the client, so it makes sense that the client should acknowledge the message to the server. And well, how long should the server wait for that acknowledgement before it attempts to resend the acknowledgement? Okay, well, that's one part of it. Well, what if the client sends the acknowledgement to the server? Does the server need to acknowledge the acknowledgement? And what happens if it can't acknowledge the acknowledgement? And there's also a case where the messages might not necessarily get sent in the order that you're thinking they're going to get sent, because a lot of this stuff is happening underneath the scenes. So there's a whole bunch of problems just with the acknowledgement model that people think that Signalr should have. Signalr does not guarantee any message. I have an article on this on my site as well. Let me go back one slide. I talk about message deliverability, and they are actually trying to build some stuff into Signalr to help make this easier. But what I tell people is, if you're connected via a WebSocket, you are pretty guaranteed, pretty close to guaranteed, like 99% guaranteed to get that message. When a WebSocket fails, it fails pretty immediately. And what happens on the client when that WebSocket fails? You're going to get an event. So the connection has disconnected. One thing that I didn't show you, you can enable automatic reconnections. So if a connection fails, it automatically reconnects. And it's kind of like the Gmail cycle. Let's connect in 1 second. Let's connect in 3 seconds, in 5 seconds, and so on. Eventually, you can get to the point where it just disconnects altogether. It's not going to retry anymore. That depends on how you handle that any way you want to. But what I tell people is, when that reconnection happens, and this is what we do in Livecat, is when a disconnection occurs, let's say it's 500 milliseconds between the disconnection and the reconnection events. We don't trust any of our state. We assume all that state's bad and we throw it away and we ask the server for new state. That is the way to go, because you don't need to play what's changed in 500 milliseconds. What messages didn't make it down from the server to the client? You don't want to play those games. What if you know your connection has severed for any reason, and you're going to have those events? You don't trust any of your state. You reestablish that state, and you just go from there. Because what could happen is, when the WebSocket is disconnecting, during that process, you could be sending a message, and that message is guaranteed to not make it, because there's nothing that's going to stop it. Signalr is not going to throw an exception. It's not going to say, oh, well, hey, I got a person over here that's in the process of disconnecting. It's going to try to send that message to every connection it possibly can. But if there's some connections it can't send it to, it's not going to say anything, because it's not on Signalr to guarantee those messages going forth. So it's people who don't like that answer, but there are ways that we can mitigate against that. You could have more concern if you're running service end events or long polling, because the disconnection events don't occur as quickly. So like long polling, because long polling is a good example, because the connection opens and closes and then immediately reestablishes. Signalr has a little bit of leniency between when a connection closes and a new one reestablishes, and it gives that connection time to reestablish itself. But it might not ever reconnect. The connection might close, and then it just waits and waits and waits. And there have been some cases where it might be up to 15 minutes before the server ever finally realizes that connection's gone and it's never coming back.
And just so everyone knows, and I'm sorry to interrupt you, Kevin, I'm going to make sure that everyone can talk. So I'm going to allow microphone for all attendees.
That's the hard answer to that question. Is you can turn on automatic reconnection. I think that's a really easy thing to do. Listen for your connection events. I had a client, losing track of time. I think it was October, November last year. And they brought me on specifically for this issue. They were trying to guarantee events coming through, and turns out the problem, their use case was, well, we have obvious reproductions where certain clients are not getting the messages that we're sending. And we dove into that a little, and they were trying to architect this huge acknowledgement model where the server would send a message and they would have the clients acknowledge the messages. And turns out they weren't awaiting their calls. So they were sending these messages down to the clients, and they were calling the task. The threads were terminating before the messages were ever sent. So obviously the clients never got the messages. So instead of building an async or acknowledgement model, I told them just go fix your code. And they did. They took a couple of weeks. They fixed all their asynchronous code to be asynchronous. And they came back and said, we have not had a single issue since we've done that. And then I also told them to go back and check for their connection events. Because if the disconnect event occurs on your client, you can safely say you are missing messages. You reestablish that connection and you ask the server for updated state. That is the best way to handle that problem.
Now, would you get the missed messages when you reestablish your state? Right.
Yep.
So are you saying when it comes to the Signalr is not something that you should rely on for transactions?
No. No. So one of the other common questions that comes up, and I'm surprised no one's asked it, is when would you use Signalr or just traditional API calls? And that's a very specific example where I would do an API call. If it's something where I need to know whether or not it succeeds or fails. HTTP is good at that. 200 okay, 201 created, 404, 400, 401, like
500.
something obviously happened.
Right.
So those are definitely cases I would, if I have a transaction that I need to know has started and gotten to a point where I can do some other stuff, I would very much use an API call for that instead. Because then I'm going to get that 201, 202. I'm going to get a proper HTTP status code. With Signalr, you're just kind of, it's the equivalent of standing outside and just yelling. It's pub sub.
Yeah.
So anyone who's done publish, subscribe in other cases, it's the same model. It's like standing outside and yelling, and anyone who's listening to you can do something with whatever you're saying. Yeah.
So would you say that this statement is true, that it's the UDP to TCP?
Yeah.
So for those of you who don't know what UDP is, because it's not is, and this is back in the day when we were really using dial-up, and when broadband meant you had a T1 or ISDN, was sort of broadband. We had UDP was a big thing. And there was also multicast. Remember that when that was a big thing, before everyone had, like 100 megabit connection at home. It's not everyone. I get it. I'm just saying. You would use UDP and people would have a UDP endpoint and you would receive data. So you would just broadcast out and everyone who's listening would receive it or not. And you didn't care that they received it or not. Unlike TCP/IP, where you actually have to send an ACK, UDP is just send it out into the ether to all those who are listening to me. And this is where multicast came up. And you hope they listened and got it. And this is a good example of going into the Wayback Machine is Real Networks, heavily used UDP. And that's how you got your quote unquote streaming audio way back in the beginning. Was they had to send it to people, but you had to send it to them en masse so that they could listen to their events, kind of like radio. If you went under the bridge with, it might go out because it was AM and amplitude modulation. Sorry, too high up in the atmosphere, you're gonna miss it. So
very much the same model.
The UDP of notification. Most of the time you'll get it.
And what's funny is it's all over TCP. So it's like
Yeah.
the UDP model over TCP. You're guaranteed to not get, yeah. But that's a really good question. And yeah, I keep talking about the course. I talk about a lot of these topics in the course. But the connection mapping, hopefully I answered your questions about that earlier. But retries and message deliverability, I have articles on that on my website. Where I try to talk a little bit deeper about those topics. Because that's one of the big requests I'll get from customers is they'll say, hey, we want to build an acknowledgement model on top of this. I'm like, are you sure you want to do that? Because there's a reason the .NET team didn't add that feature. Because it's hard, it's really hard, and it's never going to work the way you expect it to.
Shinoy says, thanks checking out your articles.
I appreciate that. Thank you.
Hopefully I pronounced that properly. Yay. Does anyone else have any questions? Heads up, the microphones are open. So the mics are open, the lines are open. Call in. Does anyone have anything where they want to talk about it?
No questions, but thank you very much, Kevin.
Hey, I appreciate it.
Awesome. Well, Kevin, thank you very much. I hope we can have you again. And
yeah, anytime.
What a great presentation. I'm going to record this. So for everyone who didn't hear it before, this was recorded, and we will end up putting it on the Indy.net Consortium website. So you'll just find the Signalr presentation. So Real-Time Revolution, Signalr in action. Click that, go to the comments, and the YouTube video will be there. It usually takes me about a day or two to get that in, but we'll get you squared away. And I think, Kevin, you might send me your presentation. There's a lot of code, but the presentation, at least we'll try to get that in there. And thank you very much. And everyone, be well and be safe.
Thank you so much, everyone.
Yay.